Okay, guys and girls, welcome back to another fun-filled, action-packed walk out of the classroom algebra 2 video. All right, so we're going to be solving logarithmic equations today. All right, because remember, logarithmic and exponential are very closely related, right? You can write an exponential equation in logarithmic form. You can write a logarithmic equation in exponential form. So there's not much to say about solving logarithmic equations. Really, you just need to see a bunch of examples to see how it goes. You kind of get a pattern, get a feel for it after you do a couple. But so we're just going to jump straight into some examples. So what does a logarithmic equation look like? It looks like this. Log base 4 of x minus 1 equals 3. There it is. There's a logarithmic equation. We need to solve it. So we're trying to isolate x and see what x could equal to make this a true statement. So how are we going to do this? Well, we can see right at the beginning, we want to solve for x, but x is trapped inside by something. What is in the way? The parentheses. And what is actually the operation there, though, of the parentheses? The parentheses is there, but what is the thing that's in the way? What? Yeah, the log base 4. That's the thing. Okay. That's what's in the way here. The log base 4 is stopping us from solving for x right away. So we want to get rid of log base 4. Now, how are we going to get rid of log base 4? We are going to use that base. What is the base right there? 4, right. And we're going to apply that base to both sides like this. The base of 4. And then now the log becomes an exponent. Like this. So I apply a base of 4 and exponentiate. That's the word, exponentiate the log. And then on the right side, it's going to be the same thing. I made log base 4 on the left side, so what do you think I have to do to the right side? I mean, base of 4, not log base, but base of 4. And what is my exponent going to be on the right side? What do you think? The 3, that's right, like this. So you can see all the original values are still there, but we added a base of 4 to both sides. We exponentiated both sides. Now, what is the point of this? Because look right here, we have 4 raised to log base 4. What happens with the 4 raised to log base 4? Do you remember? It cancels out. That's right. So what are you left with? X minus 1. And now what is 4 cubed? 64. That's right. So now you can see we're in a position to solve for x now. So what do we need to do? Add 1. And so my final answer is... there it is, x equals 65. Very good. So that's the general idea for what solving logarithmic equations are. So when we do more of these, you'll probably get a feel and become quicker and quicker at these. What? Only examples, yeah. All right, so second example then. So you want to see a bunch of different kinds, you know, so you get used to seeing all types of problems. It's going to be log of 5x. Oh, that looks like an S. Log of 5x equals negative 3. Okay, so right off the bat here, what is in the way that we want to get rid of, that we want to cancel out? The log, right? Right, in the log base 10, because you don't see a base written there, so there's an understood 10 here. If you want to, let yourself know, you can write the 10 if you want to right there. So how can I cancel that out? Right, you're going to use the base of 10. You're going to exponentiate both sides with a base of 10. So 10 raised to the log of 5x, and what's going to be on the right side of my equal sign? Right? To the negative 3, exactly. Okay, so now what is this going to result in? What happens to the 10 raised to the log? Right, so what's left? 5x equals? What is 10 to the negative 3? 1 over 1,000. Why is that? Because what is 10 to the third? Yeah, 10 to the third is 1,000, so yeah, it's negative, so that's going to be 1 over 1,000. All right, one more step here. What do you have to do? Divide by 5. And if I'm dividing by 5, then what's my fraction going to end up being? 1 over 5,000, that's right. If you're dividing the fraction should get even smaller. So, pretty much just multiplying that 5 to the bottom. So x equals 1 over 5,000. That is correct. All right, the next example is going to be log of x plus 4 equals 8. Now, some people will get a little tripped up by this. And let's see what you guys have to say. What do you think we do first when we have something like this? Subtract 4, right. The first step we should be doing is subtracting the 4. Because that 4 is not inside parentheses with the x. It's just tagged on at the end. So we're going to subtract 4 to get rid of that. Which leaves me with log of x equals 4, right. So now we're in a familiar position. Let's see. What would we do from here to solve for x? Put the base of 10, that's right. Equals 10 raised to the 4th. All right, and what would this result in? Right, you cancel out the 10 in the log, so you're left with? Right, x equals 10,000, very good.
So if it was negative, it would be 1 over 10,000?
Yes, that's right. Okay, why do you say it like that? All right, example 4. You guys are breezing through this one. Okay. Example 4, 2 times the log base 3 of x minus 5 equals 8. Now, so on this one, what do you think we would do first? Divide by 2, very good, yes. Because that is 2 times log base 3. We don't want 2 times in front. We divide both sides by 2. Which leaves me with log base 3 of x minus 5 equals 4. That's right. And now from here, right, the base is gonna be 3. So 3 raised to the log of equals what? 3 to the 4th. That's right. All right, and what happens from here? Yeah, 3 log base 3 cancels out, so it's going to be x minus 5 equals 81. That's right, actually. Yes, 81. So now we got one last step. Add 5. That's right, and you end up with, that's right, x equals 86. Very good. All right, and the last example for the first section is going to be log base 5 of 125 equals 3x minus 4. This one looks a little different than all the other ones we did, and can you recognize why? What looks different about this one? What doesn't have an x? Yeah, the x is on the other side. The x is not inside the log, right? That's the difference. The x is not in the log here. That means that you can actually find out what that log equals. Log base 5 of 125 is a number, right? Yeah. What is that number? 3. Very good. Yes. How did you get that? Because 5 cubed, the 3, is 125. So 3 equals 3x minus 4. Now can you finish solving this one? Add 4. 7 equals 3x, and then divide by 3. So that's right, 7 over 3 equals x. There you go. Very good. Woo. All right, nice. Well, I also said you guys do a lot faster than other classes too, so you know. All right, but anyways, Now, before we continue, though, we need to review real quick to make sure you understand a concept that we did before. So I'm going to cut this out. Did everyone finish writing this? Okay. All right, so we're going to review a concept that we learned before. This is a log property concept. So, spoilers. All right, remember this, express as a single log and simplify. So this is using the log properties. If I gave you log base 3 of 216 minus log base 3 of 8, how could you combine those into a single logarithm? If you want to. This is a review, but yeah, if you want to. Log base 3 of 216 over 8. That's right. Remember, log properties say that when you're subtracting two logs, they can be combined into a single log as a fraction. So there it is. And what is 216 over 8? Anytime you have a fraction, you want to reduce if you can. So what is 216 divided by 8? What is 216 divided by 8? 27. And so now we've got to this point, log base 3 of 27. What does that equal? 3. That's right. It is 3. Because 3 cubed equals to 27. That's right. All right, good. So this next section of the notes, we need to use our log properties. So that's why I'm just making sure you guys kind of remember what log properties are about. So here's the second part of the notes. I'm going to go to a, well, I'll use this rest of this for now. Okay, so if you want to, make a little header for this, you can put solving logarithmic equations with log properties. So we're still going for the same thing. It's just that it takes a little longer. It takes a few more steps to get there. So first example is going to be log base 4 of 4x plus log base 4 of 2 equals 3. All right, remember, we're still trying to solve for x here, but remember those first examples we did, there's only always one log term, right? But right here, you see there's two. There's multiple log terms. So what do you think we want to do with those log terms? Combine them into a single log term, right? So if I combine these two, log base 4 of 4x and log base 4 of 2, what would that become? Right, log base 4 of 4x times 2. When you're adding two logs together, it's the same as one single log where you're multiplying the numbers at the end. Okay, so now I want to simplify that a little bit. What is 4x times 2? 8x, right? So now we're at log base 4 of 8x equals 3. And from here, right, this should look familiar, like the first examples that we did. What can we do to solve from here? Use the base of 4, right, base of 4 on each side. Equals, what's going to be on the right side? 4 cubed, right. Keep asking you this because I want to make sure you guys don't flip it around. Some people would be saying like 3 to the 4 or something like that. What? Would it still be what? No, not this one. What would this result in?
64.
Right, so the right side is going to be 64, yeah?
8x equals 64.
Yes, 8x equals 64 because the 4 log base 4 cancels out. So 8x equals 64, and then to solve here, right, that's right, x equals 8. Very good, there it is. Whew. All right, next example. Log of 3x minus log of 6 equals 1. What do we want to do here? That's right, you want to combine the logs. So if I combine those logs, what would it result in? Log 3x over 6, right. Equals 1. Now, remember, every time you have a fraction, you want to simplify. So can you simplify 3x over 6 into what?
1 over 2.
Right, 1 over 2, but what happens with the x? X over 2. Right, it's 1/2, which is just like x over 2. So here we are, log of x over 2 equals 1. So now how do we actually solve this then? How do we finish this out? Right, 10 is the base raised to log of x over 2 equals 10 to the first power, right? So we use the base of 10 because the log right here is the unwritten 10. Okay, so what would my next step say? Right? So x over 2, 10 to the first? It's 10. The first power doesn't change anything, remember? 0. Yeah. So x over 2 equals 10. That's right. So then we got one more step here. What do we do? Times 2 on both sides. So your final answer is x equals 20. That is correct. All right, example 3. Moving into a little bit more complex, just a little bit. Log base 4 of x plus 2 plus log base 4 of 3 equals 3. So what do you suggest that I do first here? Yeah, you want to combine them. So if I combine these two, how would that look?
Log of base 4 x plus 2 power 3.
Not to the power of 3. X plus 2 times 3, right? So now here's the thing. You're multiplying them, right? So if you multiply them together, what would you end up with? 3x plus 6. That's right. It's like distributing, right? If you're multiplying these two terms, the 3 needs to be multiplied to both of the terms inside the parentheses, which gives you 3x plus 6 equals 3, right? And now it's pretty familiar. How could we finish this one out? Base of 4 equals what's on the other side? 4 to the third. Very good. And so what would my next step say?
3x plus 6 equals 64.
That's right. 3x plus 6 equals 64. Nice. All right, we're going to subtract 6. Give you 3x equals 58. And what do we do from here? Which leaves me with x equals 58 over 3. Very good. There you go. 58 over 3. Can you get a negative answer? Well, you need to be careful because remember, you can't take logs of negatives, right? So sometimes you might get a negative answer, but you have to see that if you put it back into the original, right, it doesn't stay as a negative number.
If you have 2x minus 8.
2x minus 8.
Like log 6 and then parentheses 2x minus 8.
Right.
Could you get the negative answer for that?
There could be some negative answers that work, right? But then there's also negative answers that wouldn't work. It just depends on if that 2x minus 8 turns out to be a negative number or not.
Like you subtract 2 by 8.
2x. Oh. Yeah, that one probably wouldn't work then.
I got an answer.
All right, next example, number 4. It's going to be for my next trick. Log of 2x plus log of 3 plus log of 2 equals 3. Wow, take a look at that. Take a gander. All right, what do you think we're going to do here? We're going to combine them, right? So we're going to combine all the log terms. And how would I combine these 3 log terms, though? Log, okay, yeah. That's right. It's going to be log of 2x times 3 times 2. All of these are being added, right? So you're just multiplying all the numbers together. So what is 2x times 3 times 2? Right, it's 12x. So log of 12x equals 3. And how would I go about finishing this one? Right, the base is 10. Equals, what's on the right side? 10 to the third, right. Okay, so after the exponentiating, what will my next step say? Right, those cancel. 12x equals 1,000. That's right. And so we've got one more step here. And x equals, now can you reduce 1,000 over 12? What would that reduce to? 500 over 6, which reduces further to 250 over 3. Very good. Boom. 250 divided by 3. All right, we're on the second to last one. All right, actually, we're going to call this the last one. Just kidding. We're on the last one. We're on the last one. This is the one. This is the one. This is the one that separates the men from the boys. Log base 2 of x minus log base 2 of 2 equals 3 minus log base 2 of x. Wow. I mean, it's just as many terms as the last one, but it just looks funny. So, what do you think you would do first here? Combine what, though? The first two? But then what happens with the last one over there? On the other side of the equal sign.
So you add one to the other side.
Yes, that's right. So first, we want to get all the logs on the same side. So we're going to add that log base 2 of x to the other side. All right, you guys got that way faster than I thought you would have, but that's very good. Okay. So I'm going to put this right here. Oh. Now notice I'm writing it, when I write plus log base 2 of x, I'm writing it right under the other log base 2 of x. Because if I take one log base 2 of x and I add another log base 2 of x, how many log base 2 of x's do I have?
Log base 2 of x.
How many of them do I have? 2. So I just write 2 log base 2 of x, right? Because I've got 2 of them. Minus log, hang on a second, log base 2 of 2 equals 3. Right, so yeah, you're saying you want to divide because you're trying to combine them, right? But you can't do that yet because of the 2 that's in front, right? So what can we do with this 2 that's in front, though? On the what? You're on the right track. So what are you saying? What's your instincts telling you? I think you said it right the first time, and then chickened out. So yeah, you can just move the 2 to the end right here. It becomes the exponent. Yeah. So you should have just said it. You could have looked really smart there. Come on now. So remember the power property lets you move the coefficient at the front of a log into the exponent position. So it's going to be log base 2 of x squared. So we just take the 2 and move it to the exponent's position. Then minus log base 2 of 2 equals 3. And then now, because there's nothing in front, right, we're just going to logs, now we can combine them. So now, Ronnie, what would you think this is going to be?
Log base 2
X squared times 2? Divided by 2. Remember, it's subtracting, so it's dividing. Equals 3, right? Probably could. There's different ways to do it. I'm just trying to show you, the variety. Trying to give you a little bit of everything. Take you to the buffet. All right, so yeah, the base is 2.
Log base 2 parentheses x squared over 2 equals 2 to the 3rd.
That's right, equals 2 to the 3rd. Very good. Not quite. What would this result in?
Yeah, it's 8.
2. No, it's x squared over 2.
Right, the 2 log base 2 cancels out, so you're left with x squared over 2 equals, and then as you said, yeah, 8. 2 times 2 times 2, that's 8, yes. So now, all right, you're going to multiply both sides by 2. X squared equals 16, that's right. Let's do. Square root it, so what do you get? X equals
8.
All right, now be careful, because actually when you really do this step right here, x squared equals 16, right? What could x possibly be? It could be positive square root of 16, right? And it could be the negative square root of 16, right? Those are possible solutions, right? Okay, so what's the square root of 16? But then look, right here you gotta be careful, because this is what you were asking earlier. Can you have a negative answer, right? Look at our original equation back up here. We started with log base 2 of x, right? So whatever my answer is, I would plug it back into the space where x is, right? But that can't be negative, because if I try to put that, it's going to be a non-real solution, right? So only one of these solutions can work, because we can't have that negative in the log's position. So what's the actual only answer here? Just 4, right? So the answer is, right, x equals 4, and that is it, right? Because you cannot have this, look, log base 2 of negative 4. If you put that in the calculator, you can see that's not going to work. Boom, that's right. So that was the last example for the day. So good job, guys, and I'll see you in the next one. Peace!